Hi everyone. I have introduced autocorrelation model. Autocorrelation exists when error terms are correlated. If you have some data set, autocorrelation exists, then the ordinary regression model, in other words, least square method, does not work for that kind of a data set. So now today, I'd like to introduce Durbin-Watson test, which is how to detect autocorrelation in your data set. Okay, let's see. Here, let's consider first order autoregressive model, AR1. Okay, AR1 model to examine how to detect the presence of autocorrelation. If it exists, we have to think about this kind of model. I introduced this model before. So yt equal to beta 0 plus beta 1 xt plus epsilon t. Epsilon t is a function of what? Previous epsilon, previous time point epsilon. So epsilon t is k times epsilon t minus 1 plus ut. Ut is called what? White noise or disturbance. That is, as usual, assumption about error terms. This white noise is IID normal with mean zero variance sigma square, and k is autocorrelation coefficient, and it is between -1 to +1. Okay, like this. K is correlation coefficient between epsilon t and epsilon t minus 1. Most management or economic indicators tend to be correlated between past and present values. Can you guess it? Therefore, if the residual at the previous time point has a positive value, then the residual at the current time point will also tend to be positive. So in other words, the residuals between neighboring time points often share the same sign, either positive or negative. Something like this, okay? Neighboring time points, the residuals neighboring time points has same sign, residuals. We call it positive autocorrelation. But negative autocorrelation occurs when residuals at neighboring time points have opposite signs. Therefore, in cases where the autocorrelation exists, it is generally observed as a positive correlation between residuals over time. So many autocorrelation data like this, positive autocorrelation. The method to test the presence of autocorrelation is called Durbin and Watson test. The hypothesis is null hypothesis. K is what? Correlation coefficient between neighboring errors. So coefficient between epsilon t and epsilon t minus 1. That is 0, no autocorrelation, right? And versus H1 is not equal to 0. Durbin-Watson tested statistic is like this. You don't have to memorize this kind of thing at all, because Durbin-Watson tested statistic will be given when you use some statistical software. ET is residual at t. The Durbin-Watson statistic always takes a value between 0 and 4. Here is 0, here is 4. If the computed value is close to 2, near 2, what? No autocorrelation. No autocorrelation. When there is a negative autocorrelation, the values tend to be close to 4. This part is negative autocorrelation part. But here, no decision. We cannot decide whether there is autocorrelation exists. Okay? So it's some funny territory here. What? Therefore, the result of a hypothesis test whether to accept H naught or H1 are judged based on the magnitude of a Durbin-Watson statistic as a following diagram. So mainly you can think about this part this way, this way. The Durbin-Watson dW value of dW is between 0 to what 1 2 0 to 2. This area will be given. Let's see simple example. Below is a time series data of disposable income XT and passenger car sales YT from the first quarter 1995, first quarter 1995 up to fourth quarter 2004 here, fourth quarter of 2004. The aim is to investigate how passenger car sales can be explained by disposable income, say YT regressed on XT. When we apply the linear regression model, you first apply linear regression, ordinary linear regression model. Then you obtain YT hat equal to minus this value plus 1 for 7.33 xt, and statistical software packages provides Durbin-Watson value 0.934. Since value of dw is 0.934, there exists positive autocorrelation, so that we cannot use the regular result. We cannot use this result. This is a part of output here. Okay, Durbin-Watson 0.934. Okay, so then how to adjust this kind of problem? So we will see Cochran-Olcott method next time. All right, it is not very difficult. It is simple. You have to see Durbin-Watson statistic 0.934 by the ordinary least square method. Then, if this value shows positive autocorrelation, then we have to think about another way, say Cochran-Olcott method. All right, thank you. Bye.